Hello, this is the first demonstration of Tcon, one of the turbine configuration products available from Elios. I'm going to start the application by launching an executable. This is the main user interface screen. From here, the user can choose from a series of gas tables to pick from: NIST 2009, ASME 1997, ASME 1967. The user can either pick the type of fluid, either air or water. In this section here, the user enters the operating conditions, the inlet steam conditions or inlet conditions, temperature. The user can enter pressure, and either enthalpy or temperature or the amount of superheat. The user can then enter exhaust pressure followed by turbine speed. Automatically comes open with these default values, and the user can specify single flow or double flow. These other tabs are essentially performance factors of velocity limits for the inlet flange, inlet pressure loss, shaft end leakages, the velocity coefficient, hood losses, the amount of velocity heads for hood losses, exhaust velocity limit, generator efficiencies, gear efficiencies, and pump and bearing losses. This next tab here is the steam path assumptions regarding the amount of partial emission for the first stage. You must specify the pressure ratio for the first stage and the pressure ratio for the last stage. The gauging angles for the nozzle, the gauging angle for the IP group, which is the center group of stages, or the group of stages minus the first and last stage. Stage reaction for each of for this first stage, the IP group of stages, and the last stage. And then the base diameter, you can usually put a base diameter in here of whatever value they want, or they can enter in 0, and Tcon will automatically calculate an optimized base diameter for the wheel. In this tab here, geometric factors help to dip variation. For the first stage IP group and the last stage, the axial width of the nozzle, for both the first stage and center group of stages, last stage, the stagger angle for all three groups of stages, and the same thing is entered for the blade as well too. In this regard, there's another angle here that's entered as the blade inlet angle. So we're just going to go ahead and we're going to run this default case here. Oh, and one other thing to add here is that the user can also override the number of stages based on whatever value they want. Also, this is an area where actually some dump reports, and these dump reports were mainly used for developmental purposes of the code, but they can be used for diagnostic purposes to see how various loops in the code are converging or diverging if you've got a particular issue with a set of operating conditions. So anyway, we're going to go ahead and run this case here. This plot over here is actually the velocity triangle for the nozzle in the blade. The upper triangle is velocity triangle coming off the exit of the nozzle, and the bottom triangle is the velocity triangle coming off the exit of the blade. And so as we're optimizing the efficiencies of each of the stages, and also we are converging on the overall efficiency of the turbine, and also we're adjusting the expansion line of the steam from the inlet all the way down to the end, and until we get to reach the target pressure or the pressure ratios for the last stage. And as the system's running, what's being shown up here is some feedback information to the user, showing various aspects about the actual running of the program and how the values are coming along. And one of the reasons why information is kept here is it's kind of neat to look at this stuff, as well as was used in developmental purposes of the code, and so we kind of just kept it here for just, I guess, lack of better things, entertainment for the user to actually kind of watch as this thing's running. So once it's converged, it says turbines converged. this tab on here is actually showing you the various parameters and how the expansion line. This is on the right hand side here. This is a Moeller diagram here, and it's showing you the expansion of the steam from the inlet flange all the way down to the exhaust flange. And there's actually two pressures here that you're seeing, two isobars. One isobar is the lower one is the static pressure, and the upper isobar is actually the total pressure. And the difference between isotropically, the difference between these two enthalpy values is going to be equal to the, the blade, the leaving loss of the blade. Um, this top graph over here is showing you the amount of available energy and the amount of used energy per each stage. It kind of also gives you an idea how effective the actual stages were. And this is another graph down here. And the middle graph is showing you the velocity ratio compared to like an optimal velocity ratio. The last plot, third plot on the bottom, is the area, the theoretical areas that the TCon derived for this particular turbine. The tabular output graph is essentially you select a parameter here, so some bulgy parameters here, and you can kind of span across the top here. You can go across the top and see some of these bulgy parameters here that were used in the optimization of the flow path. Nozzle parameters here. So here's the nozzle areas. Here's some information regarding the nozzles and so forth and so on here. The stage-specific information shows some specific diameters, specific non-dimensional. Overall stage shows the amount of power created in each of the stages, and some information, stage efficiency. This is turbine output essentially. If you remember, go back to here, we're actually asking for a number of horsepower, and the system is then delivering that horsepower. So there's two columns. There's two horsepower columns here. One's the gross power and the actual net power. The gross power is the aerodynamic power created by the stages. Mechanical stress parameters in here, and this is a kind of a tabularized value of the state points of each of the stages. It shows not only the inlet and the exits, but also it shows the isentropic exit state points. It's kind of a sanity check to kind of look here to see how if you wanted each one of these tables as well too can be essentially copied into an Excel spreadsheet. So you can Control C or Control C is probably the best way to get it into Excel. So once you get it into Excel, you can just kind of paste it into Excel. Going back to the application, on this sheet here, you can actually basically generate a what's called a TCon report. This report contains all the information, geometric information, all the inputs used to generate the this flow path. And within here, the same type of parameters are shown are digitized, are tabularized that are on this on the tabular output page. And additionally, all the performance factors, operating conditions, and performance factors, the standard fluid path assumptions and geometric factors are stored on their own separate tabs. So essentially, you could go in here, change this off, and do a different configuration or so forth. This is kind of a bar graph of the nozzle heights and the nozzle fluid path. Just kind of a gross illustration of what how the fluid is kind of meandering through the axial flow turbine. This tab here is a tab that is used to generate an Elias input file which you can then take over and run a more elaborate thermodynamic, aerodynamic analysis on the actual geometry of the turbine. it's going through and generating all the Elias input fields and stuff of that nature. And then what it's doing now, it's actually reading the generated data back into this user interface. So just for review purposes only, you can kind of look at what's going on and so forth and so on. So once that's done, here it is. You can actually, the system is prompting you to open the spreadsheet. You can open the spreadsheet. You can look at this Elios input file. Once it's done, then you can take this. You can tweak it. You can then once you're tweaked with it a little bit, you can then take it on over to the Elias software and run a performance analysis on this turbine, and then do some optimization regarding further optimization regarding the performance of the turbine. That's it for now, and this is the first demo of TCon, and hope you guys like it.